Hello, in this lesson, we're going to talk about how we could apply the trig functions to, a special reference angle pi over 4. And the tool we're using is we are going to apply the definitions, okay? So once again, we understand that we don't know, we haven't discussed the domain and range yet, we will. Okay, but right now we're on the stage set, right? With standard position, angle measurement, reference angle, all well defined. And keep in mind of our definition that A is an angle in standard position and the point XY is on the terminal side of the angle other than the origin, and R is the square root of x squared plus y squared. All 6 functions, their input are angles. The angles are measured in the set manner. It can be degrees, it can be in radians, and the output, right? We have 6 different outputs for the different functions because the rules are different, but they're all ratios. Input are angles, the output are ratios. So in this episode and the previous one, the next one will be stressing the type of input and the type of output we expect. Okay, so for 45 degrees, right? It's really a measure is going to be 45 degree multiplied pi over 180 degree, which is pi over 4. Okay, considering pi over 4 as a reference angle, right? So let's assume that we're going to measure an angle. Okay, we're going to measure an angle. The angle, of course, is always measured from the standard position. In this case, I'm just going to measure the angle from the standard position, but the angle I'm going to measure actually is going to be go around and comes back. Okay, so this is the angle. This is the angle. Okay, so that's our A. So A terminates in the first quadrant. Okay, and this A is, okay, I can remove this. This angle, it's measured just for our understanding. So this angle, what will be this angle? Okay, it's 2 pi plus pi over 4, right? 2 pi plus pi over 4. So that's the angle. Okay, so this angle is 2 pi plus pi over 4. Okay, that's our A. Right? By definition, in order to find the output for all these functions, we need to find the coordinates, right? We're going to pick a point arbitrarily on the terminal other than the origin. And we can pick any point, right? We talk about that, any point. So we decide we're going to pick the point on the unit circle. And so this is the point on the unit circle, x comma y. So for the same angle, so let's take a look, right? What is x? X is the horizontal measurement. Y is the vertical measurement. And the hypotenuse is 1. The hypotenuse is 1, right? Well, because this angle is pi over 4, and this other angle is also pi over 4, 45 degrees, 45 degrees. And this is the right triangle. Therefore, this is an isosceles triangle. In other words, x is going to be the same as y. So the red length and the blue length are the same values, Okay, so according to Pythagorean theorem, we're going to find x. Once we find x, we find y because x and y are the same. All right, so by Pythagorean theorem, we got x squared plus x squared equals to 1 squared. And from this equation, we're going to solve for x. So we got 2 times x squared equals to 1. Okay, and then we will divide both sides by 2. So we end up with x squared equals to 1/2. Take a square root on both sides. Okay, take square root on both sides. Okay, the square root of x squared is going to be the square root of 1/2. Square root of 1/2. Okay, and that's equals to 1 over square root of 2. 1 over square root of 2. And then rationalize it, right? We can rationalize it, rationalizing it by root 2 over root 2. So we have chosen the number 1 so that we can get rid of the radicals in the denominator. All right, so 2 under square root of 2. All right, 2 under square root of 2. The left-hand side, we're getting the absolute value of x. Okay, we just do this automatically, and then we figure out how we should get x out of it, right? So absolute value of x is going to be equals to root 2 over 2, and because x is positive, because the point is in the first quadrant, therefore the absolute value of a positive number is the same as the number, right? The absolute value of a positive number is the same as the number. That's the sentence we're using, right? So the absolute value of a positive number, okay, the absolute value of x is the same as x because x is positive. As a result, x equals to root 2 over 2. And because x is the same as y, so y is also equals to root 2 over 2. So now we have located this point, right? We have located this point. This point is right here. Okay, so this point, okay, so let me write it down. Please take notes because well, as I will have to erase them later, right? So these 2 points, this point, I'm sorry, the 2 numbers in the coordinates, right? X is root 2 over 2. And y is the blue number, which is also root 2 over 2. You can see the blue number actually is sine, the red number is a cosine, right? By definition. All right, so that's when the angle that we ended up in the first quadrant, and the reference angle happened to be pi over 4. Okay, so let's look at the second case. Okay, so understand that, right? Horizontal measurement, vertical measurement. We've been talking about these for all these functions, right? For all of these functions in the setting, but this is the complicated situation. So the function value for sine is the y, and for cosine is x, right? But anyway, so let's look at the next situation when the terminal is in the second quadrant. When the terminal is in the second quadrant, okay, so before we go on, let's put the sign of this angle, right? This angle A. This angle A we have chosen to be 2 pi plus pi over 4. 2 pi plus pi over 4 is, what would that be? 13 pi over 4? 13 pi over 4, right? 13 pi over 4. Wait. No, 9 pi over 4, my bad. 9 pi over 4, right? 9 pi over 4. 2 pi plus pi over 4. 2 pi is 8 pi over 2. So plus pi over 4, that's 9 pi over 4. So sine of 9 pi over 4 is going to be the blue number, right? The y, by definition, and that's root 2 over 2. And cosine of 9 pi over 4 is also root 2 over 2. Okay. And next, let's look at one in the second quadrant, right? So this time we're gonna just find an, we're gonna have an angle. This angle, I'm gonna choose it to be 3 pi over 4. Okay, 3 pi over 4. Okay, so let's measure 3 pi over 4. How do we measure 3 pi over 4? From the standard position, right? And terminates over here, right? Okay, terminates over there. So this angle, counterclockwise, so this is 3 pi over 4. 3 pi over 4. Okay, you can see pi over 4 is a reference angle because the terminal, between terminal and x-axis, this is the angle that is acute and a positive, right? So that's the reference angle. For the same reason, we can construct the right triangle, right? This is the reference angle, so pi over 4, so x, y are the same again. So we get the same triangle, because the point is in the second quadrant, to figure out what is A, what is X, what is Y, in the second quadrant, right? X is going to be negative because over here you can see X is on the negative side. So that's going to be negative pi over 4. And Y is going to be pi over 4, right? Pi stay the same. And as a result, we can write sine of 3 pi over 4 is equals to 3 pi over 4. 3 pi over 4 is equals to, no, not this one, negative root 2 over 2. Wait, no, my bad. It's a positive root 2 over 2. Okay, I'm taking the wrong number. It's y, okay? Sine is sine. Cosine of this angle, right, which is 3 pi over 4, is equals to negative pi over 2. So that's the case when terminal terminates in the second quadrant, and also pi over 4 is the reference angle. The third case, of course, you guessed it, right? The third case, I'm going to, actually this time I'm going to choose the angle to be A equals to negative 3 pi over 4. 3 pi over 4. Okay, 3 pi over 4. For 3 pi over 4, right? How do we measure that angle? You see, we always have to think about how that angle is measured. Measured from standard position, negative angle. So it's a clockwise, right? So that angle we got is this way. And that terminal, right? That's a terminal. We pick up a point arbitrarily on the terminal other than the origin. And we pick up the number on the unit circle because that might be the simplest. Okay, and we have the reference angle of pi over 4. Now, okay, so this angle is negative 3 pi over 4. 3 pi over 4. Okay, so with that, okay, we are going to identify the point. We're going to identify at the point. X, Y, this time both X and Y are negative. Both X and Y are negative, right? Because the point is in the third quadrant. but the reference angle is pi over 4. So this is still the same triangle as the one we had in the first quadrant, except the two sides are, the two legs are negative. The hypotenuse is still 1. So we know how long they are. We just have to make sure we get the sign into our consideration because it's in the rectangular coordinates system. So this time it's going to be negative root 2 over 2, negative root 2 over 2. All right. So now you can see, right, sine of negative 3 pi over 4, negative 3 pi over 4 is going to be equals to the y value, which is the blue, and that is the negative root 2. Cosine, okay, negative 3 pi over 4, negative 3 pi over 4 is equal to the x, right? The x coordinates on the at the intersection of the terminal and the unit circle. So this is going to be once again negative root 2 over 2. Okay. Now, last but not least, you can see how definitions are being used, right? Definition are being used. Now, okay. The terminal is in the last quadrant, quadrant number 4. Okay, quadrant number 4, let's see, I'm going to measure an angle. And this angle I'm going to measure is going to be counterclockwise. Okay, this angle. And this angle, it's going to be 7 pi over 4. 7 pi over 4. And that reference angle is pi over 4. You can calculate 7 pi over 4. What is that degree, right? Go ahead if you want to pause it, right? But I try to get you guys get used to the radians and understand that it's also the arc length of the unit circle, okay, for that piece. So this arc, for this angle, right, 7 pi over 4, the arc length from here is 7 pi over 4. It's 7 pi over how long it is, right? 7 pi over 4. So make sure you understand that. Okay. With that said and done, and this is our terminal. The reference angle is pi over 4. And then what? Right? Well, this is the same triangle, except x is a positive, y is negative. Okay. And we know the value for x and y. So in this case, right? So in this case, the angle, so we're gonna, the angle, so well, that the angle is 7 pi over 4. 7 pi over 4. Okay, I made a mess, so I'm going to clean it up. Okay, I'm going to clean it up. Okay, 7 pi over 4. The point on the terminal of our choice, right, is going to be root 2 over 2 and negative root 2 over 2. Why negative root 2 over 2? Because you see the blue is on the negative side of the y-axis, right? It's vertical, but it's underneath the x-axis. I hope you guys have that visual, above x-axis is positive, below x-axis is negative, right? So now we can use definition, right? Sine of A is y, right? Y is negative root 2 over 2, and cosine of A equals to root 2 over 2. You can also put this angle in place. Okay, you can put this angle in place because we know the value. Okay, so this is how we express. Right? So now, summarize. Right? Summarize. We have done summaries for many situations, for many situations. So what I hope that you will compare these with the special angles and non-special angles, right? We have done a non-special angle at the beginning, right? 3, 4, 5. And the others, and we also did pi over 6, right? And now we're doing pi over 4. So you may like to bring all of these tables together to compare, right? So that's what I hope you would do. So I'm gonna put these together, right? So what do we want to see here? We're gonna see a lot of things here, okay? Some of the things I'm gonna mention today, some of the things we'll mention later, but I'm asking you to observe as much as you can, okay? Because we cannot address every single aspect of it for one picture, but indeed there are lots of features that we could pay attention to. Okay? So we have one more to go. And that's right here. Okay, that's right here. You know what? I should make the graph is just a little bit smaller. So that way we can fit in on, we can see all 4 graphs when the terminals, okay, for the terminal, there. Okay, so reference angles are pi over 4, and we know how to measure angles with angle measurement, with definition, the point picked on the terminal other than the origin, right? All of that is in our mind. All right, sorry about that interruption. And here we summarize the point, we summarize, these 4 cases, right? And the point, right, x, y, right? In this case would be root 2 over 2, wait, what did I do? No. Okay, root 2 over 2, when any angle that terminates on that, on this same terminal, right? So pick up any point. So this xy, once determined, then we know the function value for any one of them. And in this case, and x is negative. In the 3rd quadrant, both are negative. And in the 4th quadrant, y is negative, right? So then we can determine, sine of any angle that terminates with the same terminal will be the y, right? And cosine of, whatever angle is gonna be the same value. They happen to be the same value, right? And on the 2nd quadrant, you can see the sign, there will be some sign changes, right? And cosine will be negative, sine is still positive. In the 3rd quadrant, both are negative. On the 4th quadrant, sine is negative, cosine is positive. And then we can determine tangent, right? Tangent of any angle that terminates on the same terminal is going to be 1, right? And tangent of any angle that terminates on this quadrant is going to be -1. And tangent of any angle that terminates on this terminal is going to be +1 because it's negative divided by negative. And the last one is tangent of any angle that terminates on this same terminal is going to be -1. Cotangent are the same because the reciprocal of 1 is the same as 1. The reciprocal of -1 is also -1, right? And cosecant and secant, I think I'm going to I'm going to leave it for you. And so cotangent will also be the same. Cotangent will also be the same. Right? So, and we're gonna, I'm leaving secant and cosecant for you to fill out the table. And so this is for the special reference angle, the special reference angle pi over 4. In the next episode, we're gonna cover one more, we're gonna cover the other special angles, which is, you know, pi over 3, okay? And then we're gonna cover all these special angles, and then we will summarize again, okay, and see what we have learned. All right, until next time, thank you for watching.